Okay. Oh, let me share my screen. I think that will help. And I will confess, even though I've already started recording, I think I might have a bit of food poisoning. So if I abruptly end the call, I will be available for office hours tomorrow all day. But right now I'm fine. It's just if I get worse. I think I'm okay. I took some medicine, but I just want to give you that heads up that I did not hang up on you on purpose. That's all. We're going to leave it at that. Okay, so module 14. So last week we focused on, can everybody see my screen? Just give me a little thumbs up, one or two people if possible.
It's just your desktop for me, not anything else.
Yeah, it's also just a desktop for me.
Oh, sorry, I think I shared the wrong screen. I did, I'm sorry. And I'm already off, oopsies. Okay, let's try that again. Can everybody see my screen now?
Yeah.
And it should say visualization. Okay, good deal. So last week we talked about the basics of what should have been a basic review of statistical, descriptive, and comparative tests for you guys to mostly review, but I gave you the code for it, right? So you may not have been familiar with things like chi-square and comparison across groups with the type of data that you had using statistical software. And so that was the brunt of what we did there. What we're looking at today is very descriptive. It does not necessarily have a p-value attached to it, but it is a critical part of what you will do when you are presenting information to your stakeholders. And so in many of your classes, I'm certain you've heard about knowing your audience, thinking about your target audience and who's going to be accepting the results that and the knowledge and the action and the recommendations that you provide. And so this is an opportunity for you guys to get some experience in thinking about that, and also how to transmit the information and bridge it into knowledge. Okay, so we'll just go through there, and it's really about humans are visual creatures, right? We're very visual. We look at each other for nonverbal cues when we communicate. Often if we see a person and they're frowning, we know that means something is not right, something's off. If they're smiling, we can assume that they're happy. There are cultural contexts to this. So when we're thinking about equity, don't fully jump to assumptions, but begin to wonder, right? So we always think about our underlying assumptions. You're going to hear me say underlying assumptions all the time, because in some cultures, if you show your teeth, it's considered aggressive. If you make eye contact, it's considered disrespectful. So think about that too. But when we're thinking about visual representations, as I started to tell you last week, your visual representation should be something that speaks for itself and stands alone without you necessarily having to interpret it. That doesn't mean you should not know how to interpret it. So you need to not only know how to interpret it, but think about how that interpretation is going to sit or land on your audience, okay? This is a fun link. If we have time, we can go back, but it shows you like what to do and what not to do when you're doing a visual representation of something. So they call it darts and laurels. I don't know if you've heard of this. I hadn't heard of this either. It's an idiomatic phrase. Darts are arrows. And so it's like what not to do. And laurels are like lauding or complimenting something. So it shows you a list of visuals, and some very old ones and some very modern ones that say, oh, this is a really good one. This was the precursor, and some very famous ones. So you can see and say, oh, this is a very informative visual for complex information. And that's the other and final reason that I think visualization is so important, is because we can make more complicated information or very boring and dry information attractive to the reader, especially if it's something that you really care about or you're passionate about. Like, let's say you're trying to engage in organizational change. This is exactly what you want to do. So I just grabbed a few for you guys, and I put the code for you. And so this is a very brief, you can adapt this code very easily for yourself. And you'll see that most of it is just generic code that you can cut and paste. Well, in this case, it's a picture, so you'll have to type it in. But it's in that same Word document in module 13 of all the code. So you can cut it and paste it from there. But basically, the first one I'm going to talk about is the box plot. So the box plot is a wonderful way to compare averages or means across two or three categories. And the reason that we can do that is that we really want to be able to see how people or things average out in buckets. And so the box plot is a very popular one, especially in healthcare delivery, because we want to look at average response, average score, average visit count, average cost, average anything. That can also be median, by the way, so you can flip them around. But so what I've plotted here for you is our two plots, one without any formatting. So this is the base code. And even this, you can take out the title. So does everybody see the top? And I'm wondering if I don't think I can annotate here. Oh, yes, I can. So this is the base code right here. Can you see my little line here? The little blue line? Yeah, okay. And I saw one little nod, so I'll take that. And so this is really what will get you there. But to help you, this is how you can personalize your code. And so, for example, this is for you for information when you're coding, but when you're presenting, you probably want to do something like this. And why is the next slide. Oh, come now. Oh, stop it. There we go. Oh, Dios mío. This is why I don't annotate. There we go. Sorry. Okay, this is why. So I'll zoom in a little bit. But if you notice, so the first one on the left is the base code, right? And please stop me with questions. You're going to have to speak up because I have you on the side, so I'm not looking directly at you. You're in my second monitor. So if you look on the left-hand side, you're going to see, and I even titled it, no formatting. So you see the information, you can infer quite a bit, right? But you have to infer quite a bit. You heard me just say that, right? And especially because you have some familiarity with the American Hospital Association data set, and you know I've taught you that 0 means no and 1 means yes. But imagine that you're presenting to a hospital vice president. So you're a manager and you're presenting and they don't know this. They don't even know the data set. That's why when you do this, it helps you to have this kind of information, right? Does this make sense? So within the code I gave you, you can actually change the font size. You can name, does anybody remember what this is? What is this command? Not the font size, just the labeling for the value of the variable. How do I label the value of my variable? Hint, this might be on the quiz. How do I get this to work?
Google it.
Look!
Just being honest.
Okay, or you can look in Dr. Shamino's thing. Yeah. Okay, there's that option. Feel like you're trolling me. Okay, can we try something else? Anybody else? Please. You're gonna see a grown lady cry. How do we label our values? So if a variable is 0, 1, how do we create labels? How do we format labels for the value of our variable?
Proc format.
Thank you! Who said that? Say it again. I think I heard 2 people. How do we do it? Everybody in unison, even if you're muted. Proc format, okay? Proc format. And how do we label our variables? So you see what I did here? This is the variable name right here on the left, right? BD tote. That means nothing to somebody. So what I did is I did what? What is this? How did I change it to hospital beds count? That's the unit of analysis, right? Number of hospitals. How did I change that?
Was it like something through label? I mean, I'm only basing it.
Yes. That's it. Sorry, I'm excited. Yay! Or Google it. Or Google it. But yes, that's a label statement, right? In your code. Very good. All right, and last one is, does anybody know what this is? That's like a little trick. That's a title statement. So if we go back to the code, you see title, label, label, and you see format. Got it? You obviously don't see the proc format here, right? So the assumption is you did, if you ever see this, you know that a proc format occurred somewhere earlier in this code statement. Does that make sense to everybody? I hope it does, because you potentially might see this on like a take-home quiz.
So I have a question about that, Dr. S. If you,
Yeah.
okay, thank you. So I understand that we indicated that it's proc format, but what if, for instance, we decided to put proc SG plot to be more specific, or is that not appropriate?
Up here?
Yes.
Well, now remember, this is calling a proc format that applies to anything that you do. So here, that's a good question. So remember, proc format occurs up here. See it?
Yes.
So it just occurs, it's like the live name. It's just like a process that isn't attached to any one data set.
Okay.
It's a filter that applies to any data set you want it to call this activity, because it's like a generic activity that you call when needed. And to call it, you hit format. See, you don't put proc again, because it goes in, see, in a proc GLM here, and then it's in a proc univariate here, and then in ours, it's in a proc SG plot.
Okay.
Does that make sense?
It
Great
does.
question. Does everybody understand that? Because I can repeat that if that didn't make sense. That's a really important logic, intuitive leap. So once you get that, that's going to make a lot more sense. And if you notice, I want you to see something here. Look at this code, VBox, category, group. Those are your 3 variables, right? See how it's continuous, categorical, categorical, right? See, that doesn't change. Do you see this here on the second one? All of this stuff, line AT, all these 4 lines from here to here, it's gonna look ugly, sorry. This is all generic formatting code. Does everybody see this? Oh, this line is really fat. I don't know how to make it skinnier, but oh well. Does everybody see that? This is all generic code that you can copy and paste to format to make it look pretty like we saw on the bottom. Because if you notice, this is all SAS code. There's no variable names here.
What if you don't have a continuous variable in this case scenario, but the VBox is there? So would you just put another categorical variable there as well, or would it change?
You would do count. So there is you would look in the previous module. Remember the statistics, and there's one for counting the categories, and it's oh gosh, I can't remember the code. I'm sorry, but basically it looks similar to this, but instead of grouping it, it counts the number that are in each one. Actually, I wonder if I put it in this one. Give me 1 second. Let me double check. Pretty sure it's in the last one though. So does everybody understand what she's asking? Kind of, sort of. So what Tamron's asking is, this is the continuous variable of bed sizes, right? So we have bed sizes in two ways, right? We have categories, it's like 8 categories, but we actually have the actual count, the specific number of beds for each hospital as well. And that's this number. And that's what we're doing here. But let me see if I can find it. No, it is in the last one. Yeah, it's in the last one. And remember though, if you have count data, so like you could do the ID because that's technically continuous. Does that make sense? So for example, let me finish this and I'll show you. But if you wanted to use like the average numbers that go in each category, you could use ID. So the ID, that's why it's important to have the ID variable. Do you know which one I'm talking about? Like the ID of your code. So like hospital ID or patient ID or whatever ID you made up. You should have a unique ID for each observation, right? So you could actually do that for each one because it'll average it out for you. So it'll average out the count for you. Okay. But I'm going to move on and we can go back to that one. But does that make sense, Tamron? There is code for that. So you would just find one that will count so it'll put it in the buckets. So here it would be the percent. Instead of counts, it would be percent. So what proportion of let's see here, geriatric services. So it would be like 10% of hospitals, 20% of hospitals, 30% of hospitals, 40%, 50%. I doubt it'll go over more than that. Does everybody understand that? So as you can see though, continuous variables do make the best numbers or the best plots. So this is another bubble plot. Now the caveat to this one is that and the caveat to all of these, if you have huge outliers, your plots start to look really terrible. So if you have, look at this, if you have really huge outliers, for example, this hospital that offers geriatric services is enormous, has enormous amount of beds. So it shrinks down all the plots. So you see how it messes with all your variables? So you do have to take that into account, and you can actually cut off the outliers because then it's harder to visualize because you do want, so you could do like the top 95% of your hospitals so that you can actually say, look, and that's another good argument for using categories. So this is another one, this is a bubble plot. If you have too many variables, so this is an argument for smaller sample sizes, and this is where X and Y are continuous or count. Again, most of you will always have count data, which looks continuous, right? Number of visits, number of beds, Medicare length of stay, things like that. And then the size of the bubbles are going to be the weight of the bubble. And you can actually use the X or Y again to like emphasize that variable. And then your group will be categorical. And so you can make these so that you can begin to see the distribution and show the variation. So here, for example, when we think about how we would interpret these, this is a really good one because it's showing you such a distinct cut point between what? Can anybody interpret this? So this is what I mean when a figure or visual should speak for itself. Can anybody interpret this or try? So the way we start, I'm gonna talk you guys through it. The way you should be interpreting or thinking is first start with information. So the facts of the case, the facts that you see, and then the knowledge that tells us, right? Does that make sense? Who wants to give me the information of one of these bubble plots? The left one is a little easier because it's very clear. Who wants to tell us the information related to the left bubble plot? Or I'll call on someone.
Majority of the hospitals are large hospitals for the first one, or that's what it looks like to me.
Okay. They're actually not the majority of hospitals. And it's really hard to get a view of the count here. It does look like that because they're very dispersed, aren't they? But that's one.
Could you say that there's more variation in Medicare payer share for smaller hospitals, and that variation reduces as the bed size increases?
That's exactly right. Does everybody understand that? And if not, ask Natalie to explain herself. She's exactly right. Does everybody understand what Natalie just said? And if not, we can ask her to say it again. In fact, why don't you say that again, Natalie?
There is more variation in Medicare payer share for smaller hospitals, and the higher number of beds you have, the lower the variation is.
Very good. That's exactly right. Now, if you don't understand what that means, that's totally fine. Just raise up your hand or something and let us know, and we will make sure that we all know, because we all go forward together. There's like totally fine. So how did you come around to that, Natalie, if you don't mind explaining?
Just seeing the, sorry, my voice is going out. Seeing the top and bottom, like along the vertical axis, the Medicare payer share, you see in the small hospital, the max is at 200, the minimum's at 0, and they're really all congregated. They're very shallow horizontally, whereas the larger, they're very wide horizontally and shallow vertically. So they're all kind of congregated around that average.
So what she's talking about is actually dispersion. So the statistical concept is what you hear about is residuals. So see how far away from the mean and median things are dispersed, right? Well, the mean really. And so what she rightfully reflected on is the fact that the further away from this invisible regression line, I really need to figure out how to, well, it's probably more like that. The further away is the greater variation. Meaning, and Medicare payer share is how much the hospital depends on Medicare payers for their total revenue. And so you can see that smaller hospitals are kind of all over the place, whereas larger hospitals have a slightly, they're still pretty dispersed, but nowhere near the smaller and even medium hospitals. Okay? Because the other thing, and so what do you think? Now that's information, right? So she perfectly attributed the information. So what could that mean based on what you guys have learned in your other classes and in general, what does that mean for hospitals, for small and large hospitals, excuse me? That's knowledge. So what can we take away from this?
I would say that the smaller hospitals, like the payer would have to contribute quite a bit more, given that I mean there's some outliers, and I think that's what's throwing me off. But that's what I'm seeing, that it can be more costly.
Okay, you're kind of close. Anybody want to help me out?
Give it a try.
In the ballpark. Luke?
I'm thinking that changes in Medicare reimbursement would have an outsized effect on smaller hospitals. That's one of the takeaways that I've got from this.
Very good. So what you're both kind of talking about is that reliance on a single payer for revenue is going to impact you when there's any changes, right? Is that what I'm kind of hearing? And so the group that's most reliant are the smallest hospitals, right? Is that what we can see here? So do you notice the difference between information and knowledge? So the information is very concrete. The knowledge is the potential consequences of that information. But the knowledge is not necessarily 100%, right? So you have, and that's the beauty of how we understand data and interpretation, because it's to give us knowledge to make decisions, but we have to also recognize the underlying caveats. Maybe they're all safety net centers, doubtful, but still. Does that make sense? So when you're presenting in the next 2 weeks, you want to do the information and the knowledge. And then we would say, and but here's what we don't know. We don't know exactly what the patients look like. We don't know, but we do know that having a higher dependency on a single payer type is not great. And that's all you can say, and that's plenty. Does that make sense? Any questions? Comments, thoughts? So this is super easy. Everybody's good? Awesome. Okay, who wants to go for the second one? Luke, congratulations. You start. Information.
I think I've already used up all my response cards for this class. I try to limit myself to 2 per class.
Information.
Medicare payer share. So similar to the one before, it looks like, yeah, same elements as before, but now we're adding another dimension of whether or not, or whether a hospital is located in a metropolitan, micropolitan, whatever that is, or rural.
Suburbs.
Suburbs?
Mm-hmm.
Why don't they just say suburbs? We're also seeing that a larger number, let's see, yeah, a larger number of small hospitals are located in rural and micropolitan areas. And so we can, you just want the information, not the takeaway yet. Okay.
Exactly. Nope, that's not you.
Yeah. All right. Well,
I know that's
the
a lot
info
easier for you. That's the info. Very good. Okay, who wants to give me the knowledge? Actually, Luke, you call on someone. And you'd be totally wrong. Just give it a go, okay, guys?
And I'm thinking, who never speaks, who never shares. Just kidding. Justin, you and I were just texting. How about you?
Sounds good. Thanks, Luke. So
I'm sorry.
So I'd say probably rural hospitals in rural areas have a lot more variation in Medicare payer sharing.
That's still info. This is the takeaway right here, guys. Remember?
Oh, okay. Sorry.
Yeah, and you're right. You're not wrong. You're absolutely right. But give me some knowledge, because now you guys have passed on into knowledge. You're higher order now, guys. Help them out. What's some knowledge? What did you learn from the last figure, and what's some knowledge here?
I think we could say the same thing, but about rural hospitals, and say that if Medicare reimbursements changed, it would probably have more of an impact on rural hospitals than it would on, say, metropolitan hospitals.
And why is that? What do we know about hospital size and revenue? Does anybody know have any guesses on hospital size and revenue, by the way? You wouldn't have learned it in my class. You would have learned it at some point in the program. Or a guess, if you will, an educated guess. Economies of scale?
Yeah, just larger institutions are more efficient. So there's less risk. Yeah, you just said economies of scale. Bigger tends to be more efficient, have less overhead.
They're able to allocate resources faster and more efficiently. Okay?
That's a better way of putting it.
And they're able, it's because I'm old. but they're also able to respond to any major changes in the market a little bit more with more health and come out of it than smaller and especially rural, i.e. geographically isolated institutions. What's another reason for that? Who has more likelihood of having more patients? Places with more people or less people? AKA customers, AKA payers, people that pay. It's going to be people in the cities, right? Okay, does that make sense? This is why you need to know your data as well. That's why we do our lit review. Does everybody kind of see how things start to come together for us? And how we jump from information to knowledge?
Dr. Shafino, in this case, could you just say that larger hospitals tend to have more resources than smaller hospitals?
Well, we wouldn't say that from this. We would say that we know in the evidence that larger hospitals have more resources. So this is not surprising to us.
Okay.
Does that make sense?
Yeah, that would make sense because I'm just thinking from my own knowledge that usually larger hospitals tend to have more resources.
You're absolutely right.
So that's why this would make more sense. But in our presentations, so since we include like one either histogram or like graph or ANOVA chart or anything, is that where you really want us to go into the knowledge to, or the information to knowledge aspect, instead of going through like, because I think for me talking through all my outcome or my independent variables, that might take too long.
That is an excellent question. So because you're saying I'm going to give you all the information. I don't want all the information. You're going to give that to me in the tables. I'm going to be able to see the information. I only want the knowledge.
In the presentation.
No. I want the tables in the presentation. I'm going to be able to see, okay, this is such a great, I hope everybody's listening to this. I'm going to be able to see the tables and the figure in the presentation, right? So they'll speak for themselves. So I need you guys to connect it and give me the knowledge. What are the key takeaways? What's the most important thing? So you'll say, as you can see here, smaller hospitals are more dispersed across payer share, thus more dependent, as are rural hospitals, which means that small rural hospitals are the ones that are more dependent on a single payer, and they're the ones that are least likely to be able to move resources. Move on. But do you see, because I can see that, so you just need to lightly show me where and then get to the knowledge. But no, I don't want you to read the table and read every variable. I want you to extract the most important knowledge from your information table, AKA your tables, and tell me what was it that you pulled that gave you knowledge. Because you only have 10 minutes, if that. Does that make sense? So it's a very simple kind of walk through what you did. Does that make sense to everybody? Does anybody have questions about that? Okay, that's a very good point. Okay, so the last thing I gave you, and honestly, pies are just fun and they look cool, but pies are very rarely like, it aggregates all the data. So I don't find the utility for me is not ideal, but I wanted to show it to you because it's kind of fun, because it adds up everything and that doesn't help me. So see how it aggregated everything? It's additive. There's other options, but I didn't love it. So it's literally counting the number of beds, which sort of makes it obvious, right? What's the obvious thing here? Well, the obvious thing, oh, and here's the code for the pie, sorry. Is that you can clearly see that the number of beds, as we saw in the bubble chart, which I found to be much more informative, is very similar here. And it's telling us all of the beds are where? Where are all the beds?
In the metropolitan area?
Yeah, which we knew that because where are all the people?
In the city.
Yeah, in the cities. So I don't know if the distribution of this is similar to the population. Now that would be interesting, right? So we would want to look at distribution of human population. So you could see, is the distribution of population, which we didn't have in this data set, the same? So are 84% of people, 84.7 located in metro areas, and 9.1 located in the suburbs, and 6.3 located in rural areas? Because that is one thing I can tell you, is that this is not equivalent. There are definitely more people in suburb and micro and rural areas. So that is interesting, but that's it. So that's your pie. So if you're going to do pies, I would recommend you do like comparative pies. Not like, that's about all pie is good for. Sorry, pies. And then the last thing I wanted to show you is when you have two continuous variables, and Jake, this kind of reminded me of you, and I was doing this with Justin at one of our meetings, and I realized this is one that I did want to talk about, which is the Pearson correlation. So it's when you look at two continuous, and it's not like the t-test, but it's looking at a correlation between the two and the direction. So it's actually a really great one because it tells you the directionality of two components, two variables. So this is payer mix, and this is bed totals, right? But this is just the numeric visualization. But you can actually make a scatter plot with that p-value. So this is one of those cool ones that you can actually add information to. And so you would look at the diagonal, because if a variable, it's going to be perfectly correlated with itself, right? 1-to-1, the value to the value. But so you would look at the opposites, and you would see that this is negative. Bed totals are negatively correlated. Bed size is negatively correlated to Medicare payer mix. Does everybody know how to read that? Does everybody know what that means?
I'm not sure about the pair.
Okay, that's the Medicare payer mix. So how about this? This might make it a little easier to read, right? And I didn't format it, so you can see I just very bluntly put it up there. So here is the extra formatting, the inset, because look what happened. This is the default, and so you couldn't read that. So what you do is you look at this, and you can start to see this is bed size on the x-axis, and y is your outcome. So that's a little hint too, by the way, a little trick for you. The independent variable is the x-axis. The outcome variable is the y-axis. Do you see that? So you would say that as hospitals get bigger, what happens? And you already know this, right, from earlier figures? It's a slightly negative correlation. So 16%, like lower likelihood of what? So it's a negative correlation, meaning as the hospital bed size increases, the Medicare payer mix percent goes down. So the dependency on a single payer goes down. I know it doesn't quite look like it, but it does.
Wait, so the pair, because I'm interpreting the pair mix as it gets higher, there's more payers.
Yes. No, this is the Medicare payer mix. It's this one.
Oh, okay.
Yeah, that's why I said Medicare. I know it's my pay mix percent. So this is Medicare. And in the previous one, I had deleted that outlier. So, but you can see that it's like this. You guys kind of see the inverse curve? And it is significant, meaning that there is a significant effect between the hospital bed size and dependency on Medicare payer mix or users, Medicare patients, which means that smaller hospitals have a larger proportion of their patients as Medicare patients. Okay.
So how would you, with the 16%, you'd say that larger hospitals are 16% less likely to be dependent upon Medicare payments?
As a hospital increases it's a 1-to-1. So 1 unit increase equals a 16% decrease in the outcome unit. So for every 1 bed increase in a hospital bed, there is a 16% likelihood of a 1 unit or 1% increase in, or decrease, sorry, in Medicare payer mix percent.
Got it. Great. Thank
Great question. Does everybody understand that? So 1 unit, 1 unit. Now, if it was positive and there wasn't a negative, it would mean it would be the other way, right? So it would say for every bed, extra bed, there's a 1% increase in Medicare payer, 16% likelihood of an increase. It's not huge, but it's significant. Well, in this case, for every 1 bed increase, there's a 16% likelihood of a decrease. Does that make sense? I hate asking that, I'm sorry. Comments on this, not make sense. Have you ever seen this? Talk about your experiences. This should be a little bit of a review of stats. Now, this is not a stats course, but I can give you lots of great information as well as the UCLA course link for you to do more stats if you want to. But the majority of your career, I assure you, is going to be frequency tables, correlation matrices, and t-tests. So when you're doing this, so that's the beauty of what you've learned this semester, is that you've learned essentially everything you need to know for like most of what you'll do. Predictive analytics, you'll do with a team. Okay. And then there's some other, this is a great link and I added some more on the page, but let me go back here as well. So this is a fantastic page as well for additional code with visualizations if you want to get a little crazy. And this is a wonderful worksheet that's been around for years, I think since I was a grad student, but it just tells you what would you like to show, okay? So just a few, so here's a bubble chart and a scatter chart. So this is relationships. This is one of the main things. Distributions and relationships are 2 of the main things you're gonna do, okay? And then here's frequencies, that's comparison. So this is categorical data. This is most likely continuous, relationship distribution, okay? The only caveats I would suggest is never do a line graph when there's no time, because you've seen people do like a histogram and then they join it by a line. Don't do that if there's no time, because you're suggesting a trend. But otherwise, the sky's kind of the limit. But it just gives you a few, this is a fun little decision tree of what you want to talk about and what you want to present. And then there's just a few more bits and pieces that you can look at. Any questions?
Yeah, Dr. Shavina.
Yeah.
So pretty much just to make sense of this all, the slides that you were showing us earlier was just examples of different charts that we could use. But then the second one is like the potential options of what we think we could use for our presentation to best represent like our analysis. Is that correct?
No, this is, well, yes, but this is for just whenever you want to reference this. If you want to, I would obviously use the code I gave you. So use the figures I gave you for the visualizations because you have the code I gave you, but you can also very easily find the SAS code for any of these.
Okay.
Doesn't mean you have to do it. It's just if you really, like if you really want to learn how to do a 3D area chart, then you can look for the SAS code for that. Not, I don't know why you would, but something like that. Does that make sense?
Yeah, thank you.
No problem. This just helps you, like if you're out of ideas, so you're not always doing the same histogram over and over, for example. Or I don't know. I love histograms, so I'm fine with histograms. But this just kind of gives you an idea of how to look at things. Because there's definitely always different ways to visualize, especially with low health literacy communities. There's also some really creative ways nowadays with software that sometimes is free, sometimes is not. Like, you know, for example, frequencies using the intensity of, like for more dramatic effect, using like individuals, or you've seen it where they have the little virus. So they count the virus and the number of people affected, or you color it in or you fill it in. Those are really great visuals, but that's a little bit more sophisticated and lower health literacy. So for your work, you'll likely crank out more something like this. So this is kind of the mid-level sophistication, if you will. Okay. Questions, comments?
Another question. So how in depth do you want us to go into the study design and literature review in the presentation? Because I know like study design, we talked, like there were a lot of different segments in like the homework that we did, same with literature review. And I honestly, like, I just don't want to take up too much time talking about those because I wasn't sure what we needed to highlight.
No, this is exactly what I want you to ask. Think of it this way. Think 2 minutes for the literature and design, and then 6 to 7 minutes for your results.
Okay.
Like bulk of your time should be on your tables and your figures and your strengths, limitations, and discussion.
Okay, thank you.
Make sense? Yeah, because you'll really bring in your literature when you're doing your tables. So it's more about, you know, here's my research question, here's why it mattered, here's the data set, here's who was asked, because we need to at least know who was sampled, where they came from. If it was just like random people, or if it was adults, kids, everybody, was it 3 people on the corner? Who was it? Okay. And is it California, or is it the whole United States, or is it, you know, your neighborhood, whatever? Great question. Okay. All right, jump in. I'm going to keep moving. And then, so I repeated the project presentation dates, and then I'm going to jump over to the assignment for the final quiz, and I'll keep answering questions and checking SAS code, whoever needs it. Sound good? All right, let me. Now, I've given you a long time to do it. I would not take this long because I don't know if that's necessarily a good idea. But so I'm not sure if this is a good idea, but I just want to make sure you guys have plenty of time since you guys are giving your presentations. So this is your take-home quiz. You're going to want to do it on the separate piece of paper. So the first one is just interpreting an information table. Same rules apply. Open note. Do not talk to each other, please. It's a trust thing. So I trust you guys to do that. You may recognize some of the authors. So remember, do not interpret every variable. It's the knowledge. So hit the highlights. This is a giant table on purpose. Okay? This is a giant table on purpose. Please select 2 of the figures and interpret them. And then there's a data management piece. And oh, look, matching. Surprise, surprise. Okay? So interpret the following info. Figure. Matching. And then write the correct code to get this table. And just submit the code. Okay? And that's it. It should look very familiar and a lot like your first assignment that you had way back many moons ago. But the idea is think information, knowledge, and then also think about what is not there. So the caveats. Oh, and that's the other thing, Tamron. In your discussion, you guys will definitely, I will be wanting you to talk about like, here's what I still need to do, or here's what, you know, the future, if I were to do this study on my own, you know, something like your lesson learned. That's in the slides. So that's something that you should definitely address. That's all I have, you guys. And we're basically, it's 2:30. So I have a few more minutes for questions, but I really wanted to make sure that you had time to ask me anything.
I have a question.
Yeah.
So for the presentations, are you going to be cutting off people if they go over 10 minutes, or will you give
Yes,
maybe like a
I will be giving you a 1-minute warning.
1 minute warning? Okay, cool. Thank you.
You might have already like talked about this somewhere, but is there going to be a discussion post like last time for the take home quiz that we can post questions, or do you want us to still email you?
You know, most people emailed me, but I can put the discussion post because, and I hope people will feel confident now to answer each other. But yeah, I can do that. Absolutely.
Okay, thanks.
Yeah. Let me write that down so I don't forget.
Yeah, I got a question for everybody. So I'm scheduled to do my presentation on the 8th, but I'm not going to be able to make class that day because I'm attending a virtual conference all day for work. Anybody on the 1st interested in switching?
Switch with
I
you if
will.
you want.
I heard Twee first. Cool. Thank you, Twee.
Okay. So remind me, Luke, so I can change the list. Okay.
Yeah, I'll shoot you an email right now.
All right.
Thanks. Appreciate that, Twee. Secondly, Justin and I are going to get together tomorrow morning at 8:30 at SDSU, kind of behind Student Union, and try to work through some SAS stuff if anybody wants to join. Just throwing that out there until the police come and shut us down for having a tiny gathering.
I need plausible deniability.
Dr. Shafino, you didn't hear nothing.
Oh my god. No, they allow outdoors hangouts. So.
Yeah.
Yeah, I mean, right now it's just the two of us, but if others want to, a couple others want to come, bring a mask, we'll spread out. We can all be
Dude,
stuck
that
with
is-
the mask together.
You know, honestly, I think one of the things that I miss the most is the in-person, because coding is so much more fun in person. And just interpreting your results, because then you're like, oh, look, did you see that? And, you know, you can see each other's results. And then each of you can kind of pick out the whatever's significant too, that you didn't realize, like putting the two together to get to the knowledge part becomes fun once you've practiced it, because most of us are really good at information. And that's what you saw when you did the very first quiz. Everybody's great at information. It's that knowledge, that next bridge. That's what you did here this semester. Okay, any more questions?
I have a question. So for our graphs, so you only want us to do a graph for the most important variables, not all of them?
You graph whatever you want to share.
Okay, got it.
But remember, there's only a minimum. You're only allowed, well, what did I say? Did I say a minimum or a maximum? I forgot. I think I said at least one. So, but you remember, be mindful of your time, because when you're doing an executive presentation, like in the C-suite, you also only have a limited amount of time. So you got to think about what is it that was most important. It better include your outcome, and then whatever your primary input was, your primary independent variable. But let's say that wasn't the coolest one that you found. Let's say another one of your variables was way cooler in what it did or its behavior, then put that one up. I mean, whatever you want.
And then when we're presenting our table 0 and our table 1, do you kind of want us to just show it and throw it up there, or do you want us to go in depth and explain it?
Remember, you have about 6 minutes, so be mindful and just say, you know, here are my frequencies, because remember, you're turning in your slides to me. So I do want it in there because I'm going to look at your slides. But, and you saw the rubric. So there are points for the slide deck and then the presentation. So, and does everybody remember the rubric? We can pull it back up if that helps. Okay, where is it? I lost it. I lost the rubric. Does anybody? Oh, there it is. I was like, okay, I lost it. Why didn't I make this big? Why does it have to be downloaded? That's annoying. Let's fix that. There we go. So if you look, there's the presentation and then the content and then the delivery, right? So while you're presenting, this will be part of that structure and the delivery, and then the content to a certain extent, but then I will also go back and review it. So if you, that's why I don't want you to spend a whole lot, like you're talking about the frequency table versus the crosstab?
Yeah.
Yeah, then you would probably just say, you know, in that you maybe one or two important things like most of my people were, or hospitals, or I forget what your unit of analysis is. Most of my sample was this and this. And then comparing it across my outcome in the next table, this. Does that make sense?
Yeah.
Imagine that you're trying to entertain a CEO and keep their attention. But everybody in your class is a CEO. So you're going to make it relevant to your audience. Does that kind of help or?
Yeah.
I can't wait to see these. I'm so excited. Is everybody else excited? Because you guys, do you understand being able to get your own data, manage it, prepare an empirical presentation, and to do this is a big deal. I know nobody looks super excited, but it's a BFD, okay? Google that if you don't know what it is. Ask Luke. I can't hear you. All right.
Exactly.
More SAS. Everybody just wants to stay here with me for moral support. I got you guys. Thanks, Thelma.
You're welcome.
Aw. But yeah, at the end of the day, it's really just about a culmination of really finding information and being able to share it. Cynthia, were you going to ask me a question?
Yeah. I was just going to ask if you'd be able to stay on for a few minutes if nobody else is.
Right here. No, you're going to do it in front of everybody, though.
Okay, that's fine.
We're family here, so just put your SAS up there.
So, well, it's just a general question first. So I'm looking at industry and occupation, right, as two of my dependent variables. But there's so many different categories. Like there's.
You mean independent, right?
Yeah, sorry. Yeah,
Okay.
dependent is health status, sorry. There's so many different variables. There's probably like 15 in each category. So obviously I want to collapse them, but I'm trying to figure out how to group them. And like, according to the literature, it seems like the manual labor jobs are the ones that, you know, have the worst health status report. So I'm debating, like, should I just put it in as like manual labor and then, yeah, okay, just group them.
Absolutely. So do you know how to do that? That's a conditional statement, right?
The if then.
Then.
So the only thing with that too is it seems like the statement that you were helping me with, it was numbers, right? Like if you know, the variable and then occupation equals 1. Is there a way to do like occupation equals and then do an actual word?
Yes. Yep. Do you have your SAS window open?
No, I can open it though.
That's okay. If it takes you a minute, I'll put mine up and we'll start and we'll play with it. So I'll show you. So, oh, actually mine's not open. Let me see if mine will wake up and we'll get a SAS window up there. Has anybody done a conditional statement with character variables? I'm sorry, with character values. Because that's what we're about to do now. So this is actually a great example for that. So my SAS fell asleep, but it's waking up, and then we'll do that. So let me share. Feel free to take a break, or like I said, this is what it is. It's just questions for individuals, but it's also a great opportunity for troubleshooting and learning some code. If my SAS will sign in. Come on, SAS. Cynthia, see if you get there before me because I'm kind of struggling. Okay. Come on.
While your class is starting, I have a really quick question. Some of our other classes were like letting us present, and then if there was like feedback, we could like edit it after the fact and then submit it. And I can't remember if that was this class or another one.
This class.
Okay. Perfect.
Yes.
So we submit it beforehand, we present it, we get the feedback and stuff, and then we submit a final after.
Yes. You
Okay.
don't submit anything until after. So what
Okay.
happen is you present, you get feedback from me and the students, and then you have until that Friday of the week that you present to submit your final. And if you need an extension, just tell me. I told you, pandemic extensions are in play.
Thanks. So hard to keep all these classes straight, so I appreciate it.
Yeah, of course. Yeah, this is the class. Well, it might be others though. I don't know. Hopefully it is. But yes, because I am looking at your presentation. And at the end of the day, what you'll have is a sample presentation if you need to give a job talk, for example. So when you interview, you may have to give a talk about, for an interview, you actually have a talk now and say, this is an analysis I did for one of my classes. This is the data. I extracted it, I managed it, I recoded it, and here are the interesting results I found. So give you all your money.
Oh, I'm sorry. I got mine up and running.
Oh, good. All right. Well, I got mine going too, but let's share yours because I'd rather you have your code.
Okay.
Let me unshare and you do yours. You should be allowed to share. Yeah.
Professor, really quick, where did you put the coding for the graphs we did today?
The analysis sample. So it's on a Word document in module 13 lab. But it's a SAS file in Dr. S. My folders.
Okay, gotcha. Thank you.
So you have to like click through a bunch. All right, Cynthia, I see you. Okay, guys, help her out. So let's help her out. So this is the numbers. These are the numbers, sorry.
So I want them to be in 3 categories. I want, well, 4, I guess. So I want one to be like low education, one to be mid education level, and then one to be high education level.
Yeah, that's fine.
Okay.
But but you're doing well with it being numeric because it has to be a number for you to do the frequencies. So then you do your format statement, right?
Mm-hmm.
Now, what you will do is go up to the top. I saw it in your proc format. See all these? So pick that first one, management business. Which one is the one that has the manual labor or whatnot?
Yeah, this one.
Okay.
Their occupations.
Okay. Do you see that one? That's the value.
So then I can just group them that way based on what
the number.
Okay, I see.
The words are the label. That's the proc format already. It's already formatted. You don't actually need your data. The reason it was such a pain in the butt to pull in because it's already formatted. So that was the one benefit to your data.
Oh, okay.
Yeah, I know. So, but you do need, when you recode it, you will need to do a proc format for the new codes. So what you'll do is, so let's go down and do you know how you want to recode it? Why don't you copy and paste all that? No, not that.
Oh, sorry. Oh, you're talking about just this part?
Yeah, just that, the values,
what if
6, 8 MF.
What if we start with these ones just to make it easier, the education ones? Because that's the one I was looking at.
Okay, actually, this is good for everybody too. Copy that and paste it down here so I can see it when you're reformatting.
Okay.
So paste it down here. She's going to delete it after. We're just looking at the numbers. So what I would recommend, you want to do less than high school and then any college, right? So 13 through 17 or what?
Yeah, I was gonna do, that's the thing, I need advice on this too, I guess. So I was gonna do these ones like low education level, even though it's not really, but I just need to group it. And then I was gonna say this one.
Typically we do high school or less.
Okay.
We don't say low education. We would say it's just, that's
rude. Yeah.
Well, and then we say, we would say college. So that's 13 through 16.
Okay.
And do me a favor, hit enter. Hit enter after the 12 so we can put a little white space so I can see. There you go. And then 17 is its own, it's post-grad. And then 97, 98, 99, I would set to missing. So this one is going to help all of you because all of you have these weird ones. So when you have these weird ones, just throw them away because they're not helpful, especially if they're important to you. So you set them to missing, meaning that they don't go into the equation. So here's how you do it. Does anybody want to give this a try, by the way, with coding? So go up here, go up to PB04014, and you only need four lines of code. So you do if PB0, go up to the top, go up here, there you go. If PB014 in, and delete that first line. Yeah. And then delete the first else. No, just delete that first else. I'll get it started. And then you put in 0, comma 1, 2, 3. Yeah, you can put all the numbers in the same spot. No, get inside that parenthesis. There you go. And the 12.
Oh, okay. I see.
There you go. There. Now, do you know what to do next?
Then I'm gonna do.
And everybody else help her if she gets it wrong. You're missing one.
15 and 16.
There you go. Very good. Oh, delete that third line. You did it twice. Yeah. Now, how does she set the rest to missing? Anybody?
Is it something like dot M or M dot?
No. Close dot. Which ones does she have to set to missing?
97, 98, and 99.
So what would she do similarly to what she's done earlier?
I know that in my code book, it had like for missing data, it had like the M and then the period, but I don't know about this one.
There you go. Remember here, the dot means missing, right? There you go. And keep this one too. If it's anything else, it's also missing. So do you see the difference between the next to last line and the last line? If it's 97, 98, or 99, it's missing. And then if it's anything else, AKA missing, it's also missing. Do you see the difference between the else if 97, 98, 99, and then the else?
Yes.
That's the key. And that's it, you're done. Now run it, just run, you can delete all this stuff.
Okay. So then I wouldn't need to go back and change these, like recategorize these to like, for these 3 to equal 1, like 1 equals.
Oh, you will, because you just made a new variable. So yeah.
Don't do it yet.
Yeah, you'll need it, but don't do it yet. Just delete all that and run the data step.
Should I run the whole thing? It might take a while.
No, just that first data step.
Okay.
Just that, right? Just there. That's gonna take a while, you said? Oh, you didn't do your library, your live name. Up top, you gotta connect it. It doesn't know it's working.
Oh, I usually do this and do like command. Does that? Sometimes that'll work, you know, so it'll highlight both.
Oh, really? I didn't know you could do that. Hey, something new every day. You guys hear that? You can do multiple lines at once. I mean, that are not next to each other. Huh, is that on a Mac or? It doesn't?
Yeah.
Look at you. Okay, so does everybody understand that? And then what you'll do after that, Cynthia, is run a proc freak on both, the old variable and the new one, so you can cross-check it, like eyeball test.
Okay.
Good job. All right, anybody else? Anybody else have questions, comments, thoughts?
I'm looking at your your code for the bubble plot. And I'm just kind of trying to figure out why you chose like the 1700 and the 400 as cutoff points. And then,
Great question.
yeah, and
It
just
made
like
it
the
look
X1.
ugly.
Oh.
Outliers. I had outliers and
Mhm.
they were squishing everything towards the 0 point.
Okay. And then I'm looking at the line where you have X equals BD tot, and then Y equals. So what's the size equals? And then why is there like a slash and then group equals beds?
That's what your the color comparison. So if you look at the color coding, that's the differences.
Okay.
Make sense?
Kind of.
Now what you should do is play with it with your data so you can see and put your variables in there and see what happens.
So if I wanted to like not have any cutoff numbers, do I just not use that whole line of code?
The where? Yeah, ignore the where.
Okay.
That's a great question. I should have addressed that. Thank you for touching on that. If anybody wants to do a bubble plot and doesn't know what we're talking about, ask Kira.
Please don't.
What, you got this. You're understanding the way that, so what I love about your questions right now is that you guys are understanding the logic. And that's really the key, because once you understand the logic, you can do anything you want. And by the way, there are point and click versions of SAS, but we don't have them because this is what we have access to. So you are actually programming in SAS. You're not just pointing and clicking. And the reason that that's great is because it helps you see exactly what's happening with your information. And that is something that's very unique, and that's what makes it harder than programs like SPSS. And in some cases, Excel, although I have seen that Excel does make some beautiful figures. So I do have to say, like I said, just toggle between what works. You can put both variables in the same step, dear. So just go to the PB014 and hit space and education. Now run that. And so this is what Cynthia will do to make sure that her new variable has the 3 categories she desires and looks like it should. So it looks like variable education. Oh, go back to your code. Did you use the same? Did you use the right? You have a new data set.
Oh, I need to use this one.
Yeah, because that variable doesn't exist in your old data set, does it?
No.
Other questions, comments, thoughts? Is anybody planning to record their presentation, or is everybody going to do them live? And we will record them all, by the way.
I might record mine.
Okay. Then just be ready to share your screen and play, because I did want to address that.
Okay. Thank you.
Yeah, no problem. There you go. You see how much cleaner that is for her?
So now I would just do this for the rest of the variables.
For whatever other variable you want. And then you would do the proc format statement for education, not for PB014.
Okay, I see. Thank you. That helped a lot.
No problem. No problem. Great work. That looks beautiful. All right. Anybody else? And I'm not in a rush, so I'm here. Justin, is Justin still here? No, he's gone. Okay. So I had a meeting with him, but we met already, so I don't think he needs that meeting. Does anybody else have code they want me to look at? Or I'm going to stop recording, and then we can I can answer any other questions that you have, even if they're not specific to any one thing.